Today is day 3. This is video 2. First video was on GCF, greatest common factor. Today is difference of squares. So this part of unit 8, we are learning how to factor all of the other things that aren't covered by A times C that add up to be B. So this one is difference of squares. We like to abbreviate it DOS. And there's specific cases of when you can use difference of squares. So let's talk about when you can use it. 3 things need to be in place in order to be able to use it. The first thing is there has to be 2 terms. There has to be a minus in between. That's why it's called difference of squares. Difference meaning that there's a minus. And then really important, both terms need to be perfect squares. That's why it's called difference of squares, because they're perfect squares. Now, you may be asking yourself, well, what's a perfect square again? A perfect square is a number created by multiplying another number by itself twice. Now, that's a lot of words. Might not make sense to you. So let's look at some examples. 1 is a perfect square. 4 is a perfect square. 9 is a perfect square. 16 and 25 are perfect squares. What do all of those numbers have in common? Well, 1 is 1 times 1. 4 is 2 times 2, a number times itself twice. 9 is 3 times 3. 16 is 4 times 4. 25 is 5 times 5, and you can keep going. 36, 49, and so on. Now, you're not just going to be having numbers with these. You are also going to be having variables. So variable examples, x squared is a perfect square. X to the 4th is a perfect square. X to the 6th is a perfect square. X squared is x times x. X to the 4th is x squared times x squared. X to the 6th is x to the 3rd times x to the 3rd. So what do you notice about all of our variables that are perfect squares? Hopefully you notice all the exponents are even. Even exponents are always going to be perfect squares. Odds, no. But evens, yes. So if you have those 3 things in place, if you have 2 terms, a minus in between, and both terms are perfect squares, what you're going to do is these 4 steps. The first thing is you're going to make 2 sets of parentheses. Then you're going to put the square root of the first term and put it at the front of the parentheses. Then you're going to take the square root of the second term and put it at the end of the parentheses. So 2 sets of parentheses. It's going to have 2 terms in both. And then 1 parenthesis is going to get a plus, 1 parenthesis is going to get a minus. And those are the steps. That's it. So here's the first example. X squared minus 16. First thing, there's 2 terms. Check. There's a minus in between. Check. X squared is a perfect square. It's an even power. And 16 is a perfect square. So I start out setting my 2 parentheses. I take the square root of the first term, so the square root of x squared is x. I put that at the front. Square root of 16 is 4. I put that at the end, and then I make 1 parenthesis with a plus and 1 parenthesis with a minus. It is that easy. Second example, 4x squared minus 81. 2 terms, minus in between. Great. 4x squared. First off, everything has to be perfect. So is 4 perfect? Yes. Is x squared perfect? Yes. So both the number in front, the coefficient, and the variable both need to be perfect in order to be able to use perfect squares. Difference of squares. Minus in between, great, and 81 is perfect. So let's go ahead and set it up. You've got your parentheses. Square root of 4x squared is 2x. That goes in the front. Square root of 81 is 9. That goes at the back, and you make 1 plus and 1 minus. It really is this simple. If you were to multiply these 2 factors back together using box method or FOIL, you would get that 4x squared minus 81. And you can always check. Always check. So I have 2 for you to try. I want you to try this one first. Make sure you've got those 3 things in place. Make sure you've got the perfect squares in front, perfect square in back, and a minus in between. If so, go through the steps. So you should get 6x plus 11 and 6x minus 11. The square root of 36x squared is 6x. Square root of 121 is 11. Put 1 plus and 1 minus. And the order doesn't matter. If you want to put the minus 1 first and the plus 1 second, that is totally fine. That order does not matter. The 6x and the 11 do matter. The 6x needs to go first, and the 11 does need to go second. That does matter. Another one for you to try. 25x squared minus 64. You should get 5x plus 8 and 5x minus 8. Again, the square root of 5x, square root of 25x is 5x, and the square root of 64 is 8. You make 1 plus and 1 minus. All right, I have one last one. Going through the steps, parentheses, but is 2x squared a perfect square? X squared is perfect, but 2 is not. So it's not perfect, which means this one is not factorable. Now, in a hypothetical, maybe that 2 could GCF out and what was left would be perfect, but 2 doesn't go into 81, and so we can't go any further with this one. So this particular example is not factorable using difference of squares. And that is difference of squares, day 3.